Hello guys, good morning. You are welcome to my YouTube channel, the SPC Tutorials. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, we shall be discussing Physics 111, Chapter 1, Measurements and Units. Now, in this topic, we are going to be discussing fundamental quantities, derived quantities, and what? Dimension. And same topic, we'll be discussing or proving or disproving if a quantity that has been dimensionally gotten, if it's what? Correct or incorrect. Now, what is the meaning of fundamental quantity? Fundamental quantity, or what are fundamental quantities? Fundamental quantities are quantities that are independent on other quantities, all right? That they are independent on other quantities, which means that they can exist by themselves. They do not depend on any other quantity. Now, what are some examples of these fundamental quantities? We have the mass. The mass, of course, is measured in kg, and kg in this case does not stand for kindergarten. All right, it represents what? Kilogram. Stands for what? Kilogram in this case. Now you have number two called what? Length. Length is the second fundamental quantity, and the SI unit is meter, a small letter m. Okay, and you have number three called what? Time. Time is measured in what? Seconds, denoted as what? Small letter what? S. Okay, now in physics, as a science subject, these are the three most fundamental what? Quantities. Okay, these three are the most fundamental quantities, but you have some, but these are the most commonly known fundamental quantities. Now you now have others such as temperature. Temperature is a fundamental quantity and it is measured in Kelvin. That is K. It's measured in Kelvin. You have number five, luminous intensity. Luminous intensity is a fundamental quantity. What is the SI unit of luminous intensity, or how is it measured? It is measured in candela. All right, the SI unit of luminous intensity is what? Candela. Candela. Okay, you have number six. You have number six, current. Current is a fundamental quantity and it is measured in ampere. Ampere, big letter A. It is measured in excuse me, it is measured in what? Ampere. Okay, we now also have number seven, which is the last one for now. So you have quantity of substance. Quantity of what? Substance is measured in mole. Is measured in what? Mole, small letter n. So these are the fundamental quantities that exist in the world of science for now. All right, so mass, length, and time, I said, are the most commonly known fundamental quantities. Which of these make up fundamental quantities? Option A will always be this, and any of the options will always be kg, meter, and what? Seconds. Take note of that. The other word is derived quantity. Derived quantities. Now, if something is derived, it means that it is gotten from a particular source or a thing. All right, if something is derived, it means it is dependent on other quantities. Now, if fundamental quantities are independent on other quantities called the derived quantities, it means that the derived quantities are dependent on the fundamental quantities. Examples are you have density. All right, you have mass. It's not mass. Volume. You have volume. You have velocity. You have acceleration. You have acceleration. you have moment, you have impulse, all right, you have momentum, you have momentum, you have force, you have work done, you have you have acceleration, you have moment, you have impulse, you have a lot of them: density, pressure, stress, Young modulus. All of these are derived quantities, but these ones are fundamental quantities. Now, since we've been able to write out these fundamental quantities and some of the derived quantities, now let us start deducing dimension. Let us start deducing dimension representing fundamental or derived quantities. Okay, now please, in fundamental quantities or in dimension regarding these quantities, we make use of big letter M, we make use of M, L, and T. M stands for the first letter of mass, L stands for the first letter of length, and T stands for the first letter of what? Time. But in units, we make use of kg, right? In length, we make use of meters, as said before, and time, we make use of what? S, which is second. So please, in mass, we make use of MLT, but in units, we make use of what? kg, m, and what? S. Take note of that too. Take note of it. It is very important. Now, let us start with number one. What is dimension of velocity? Which is very simple. It's very simple. Now, velocity, dimension of velocity is simply what is velocity? Velocity means change in distance per unit time or with respect to what? Time. So, oh God, what kind of matters are these now? So you have distance over what? Time. You have distance over time. Now, distance, of course, is measured in length, just as I said, length, and time is measured. Since it's dimension, we are picking the first letter, which is what? T. Now, as soon as this T goes up, this idiot should leave this place. Now, as soon as this T goes up, it becomes what? LT minus what? 1. It is minus 1 because it has crossed this division sign, okay? Once it goes up, it becomes what? Minus 1. Initially, it was plus 1. It becomes what? Minus 1. Okay. Now, number 2, let's deduce for acceleration. Acceleration, the ministry is moving, is progressing. What is acceleration? It means the change in velocity per unit what? Time. So we say velocity over what? Time. Velocity over what? Time. So velocity is what? LT minus 1 over what? T. But as soon as this T goes up, it becomes what? T minus 1. So T minus 1, you have T minus 1 times T minus what? 1. And this becomes LT minus what? 2, because minus is what? Minus 2. So that is for that. Excuse me. No, it's not easy. Alright, I'm sweating like. Now the next one we are going to be deducing is let's deduce for force. I think I will have to unseal this new marker. Force. Force is mass times what? Acceleration. Force is what? Mass times acceleration. Force, mass is big letter M. Acceleration is what? LT minus what? 2. It therefore means that it's what? M minus what? 2. This in this dimension, but in it becomes what? Minus 1 minus 2 kg minus what? 2. If you want to say this, you say meter per second squared, kilogram meter per second what? Squared. That is how it is what? Pronounced. Now, okay, let me unsee this marker. These markers are disturbing me. Number 4. let's deduce for, okay, let me give you momentum. Oh God. Kind of markers are this good. Now momentum is mass times what? Velocity. Momentum is the product of mass and what? Velocity. Mass is big letter M. Velocity is what? LT minus what? 1. As initially what? Deduced. So this becomes MLT minus what? 1. Okay. Please take note, impulse and momentum have the same dimension. So they are dimensionally what? Equal. So impulse, okay, let me take it up. This becomes MLT minus what? 1. So impulse is equals what? Momentum. Alright, momentum. Now impulse is force times time. Force times time. Okay. Then momentum is what? Mass times what? Velocity. Force, you know, is what? MLT minus 2. That is big letter M minus 2. Then times what? This T. Now equals, our momentum was giving us MLT minus what? 1. Okay. Now minus 1 plus, there's an invisible plus 1 here. So minus 1 plus 1 is what? Minus 1. Minus 2 plus 1 is what? Minus 1. Minus 2 plus 1 is what? Minus 1. It therefore becomes MLT minus 1. You also have MLT minus 1. It therefore means that impulse and momentum are dimensionally what? The same. They are the same. Okay. Now the next, where is the border bar? Oh my God. Okay, now that is for that. What about stress? Please, stress, Young modulus, and pressure have the same dimension. Stress, pressure, Young modulus have the same dimension. They have the same dimension. They have the same dimension. Now, force. Okay, is it force now? Pressure. Pressure is force over what? Area. Force over what? Area. Now force is what? MLT minus 2. Area is what? L raised power 2. Because area is length times length, which is what? A length squared. You have one L, you have two L's. Remove one L from here, you are left with what? One L. It therefore means that M, then one L, the L remaining here goes up, it becomes what? L minus 1, then T minus what? 2. Stress also is what? Force over area. Stress is force over area, and pressure is what? Force over area. They have the same dimension, as well as Young modulus. Young modulus is stress over what? Strain. So Young modulus, stress, and pressure have the same dimension. Take note of that. The three of them have the same dimension. They have the same dimension. Do not forget that. Okay, the next one is density. Let's take density. Density. Now we've proven that impulse is dimensionally the same as momentum. We've also proven that pressure, stress, and Young modulus are dimensionally what? The same. Okay. The next one is what? Density. Density is what? Mass over volume. That is density. All right. I told that in dimension we don't write kg. We make use of a big letter M. Then volume is L cube, which is length times what? Length. It therefore means that ML raised by what? Minus 3, because it has gone up. All right. That is what dimension. Now, what about work done? Work done is what? Force times what? Distance. Force times what? Distance. Which means that force is mlt minus 2, then times what? L. That is distance, you know. So this m, there's an invisible plus 1, that becomes L2. Then you now have what? T minus what? 2. So work done is ml2 t minus what? 2. Now, work done has the same dimension as moment. Moment is also force times distance. Moment is also called what? It's also force times distance. I think these ones also have the same dimension as Boyle's law. Yes, Boyle's law. Okay, I think let me prove it. You know, Boyle's law states that the volume of a given mass of a gas is inversely proportional to its what? Pressure, divided provided that the temperature is kept constant. Boyle's law states that the volume of a given mass of a gas is inversely proportional to its what? Pressure, provided that the T is what? Constant. Provided that T is what? Constant. Now it means that PV equals K. Because if I should eliminate this proportionality sign, I'll produce. Okay, let me just do it. Let me do it. So V equals what? K over what? P. All right. I've introduced this constant K in order to eliminate this proportionality sign. So it becomes PV equals what? K. So I said that work done and Boyle's law have the same dimension. Let us prove it. How correct is that? How correct is that? So it means that Boyle's law is PV, then work done is what? MLT minus what? 2. Pressure. What did we get as pressure? Oh, I've forgotten. Is it not ml minus 1 t minus 2? I guess that was what we had as pressure. Then times volume is what? L cube equals ml2 t minus what? 2. All right, you have mass. Now minus 1 plus 3 is what? 2. Because we are just like saying 3 minus 1, and that is what? ml2. So t minus what? 2 equals what? ml2 t minus what? 2. Therefore, 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 work done, moment, and Boyle's law. Therefore, work done, moment, and Boyle's law have the same dimension. So they are dimensionally what? The same. Take note of that. Take note of that. Now, what is the next one? What is the next one? Okay, let's prove that the volume, let's prove that V is equals pi d cube over 4. Now this is what? The volume of a sphere. The volume of a sphere. Let's prove it. Now in dimension, pi, figures, and other constants are neglected. I recap. I said in dimension, figures and constants are what? Neglected. They are not considered. Now, if I have volume is length times length times length, and that will give us L cube. Then you now have D cube. This D stands for what? Diameter. Now diameter is what? Length. It therefore means that L cube. Therefore, V is dimensionally the same as what? This. So it is dimensionally what? Correct. Yes or no? Yes. Now the next one, let's prove that V is equals what? 2ax. Now I can also say that V is equals root 2gr. Now this formula is what? Escape velocity. Now what is escape velocity? Escape velocity means the energy required for a body to leave the surface of the earth. Excuse me. Please excuse me, I'm sorry, but I'm sorry. It was someone that knocked on the door, okay? Okay, so we stopped at escape velocity. Now I said it is the energy required for a body to leave the surface of the earth to what? Space. Okay, now this is velocity. And this is what? 2g r. 2g what? R. Now velocity is what? Lt minus 1. And you have this to be 2gr. Now 2, okay, should I say, okay, let me make it 2ar. That is 2a, okay. Now acceleration is what? L. I told initially that 2 is what? Neglected. This 2 is not to be considered. So then times what? L. That means Lt minus 1 equals what? Lt minus what? 2. Now this L and this L, alright? This L and this what? L. It therefore means that we now have L2 T minus what? 2. You know there's a root here. There's a root. Now it therefore means that we say Lt minus 1 equals the 2. This root is a 2. So 2 into this 2, you have L. Then 2 into this 2, you have 1. So t minus what? 1. It therefore means that velocity is dimensionally the same as what? Root 2ar, which is what? R is distance, a is acceleration, and 2 is not to be what? Considered. So this is the formula of what? Escape velocity. So it is dimensionally correct. Take note of that. Now let us also prove that, let's prove that V is the same as, let's prove that V is the same as U plus AT. Now let's prove it. Now in velocity time graph, at rest or from rest, U is always what? 0. So V is equals what? AT. Alright. Now this Lt minus 1. Then acceleration is what? Lt minus 2 times what? T. Times what? T. It therefore means that Lt minus 1, okay, is equals Lt minus what? There's plus 1 here, minus 1. So the both, which means that this entity is what? Dimensionally correct. That is what? Case what? 1. Then case 2, if I have V is equals U squared plus 2gs. 2gs. S here is what? Distance, and G here is what? Gravity. But let me use A. That is 2as. Now, this one is always what? 0. So it's not to be considered as well as what? This figure. So it becomes Lt minus 1 equals Lt minus 2 times what? L. Yes or yes? Yes. Because distance means what? This S represents distance. Alright? So I now have that Lt minus 1 is equals what? L2 T minus what? 2. So it means that this one is not dimensionally what? Correct. It is what? Incorrect. This is what? Case 2. Hope you are following. Now case 3, if I have that S distance is equals ut plus half at squared, is distance dimensionally the same as what we have On our right hand side, we don't know. Distance is just L. Now, if U is 0, it means that everything here is automatically what? 0. And it means that these two is to be neglected. It does not follow. You now have what? AT squared, right? AT squared. Length is equals, acceleration is what? LT minus 2 times what? T2 times T2 times T2. Now it means that L is equals, now you have minus, there's an invisible plus 2 here, minus 2 plus 2 is what? 0. It means that you now have that L t raised by what? 0. And according to the law of indices, anything raised to the power of 0 is what? 1. It therefore means that L times L is equals what? L times 1, which is same thing as what? L times what? L. So which means that L equals L is very, very correct. L times is equals what? So it is very, very correct. Take note of that. Take note of that. It is very, very important. So is there another one I have to prove? Okay, let's prove that um, the area of a triangle is half base times what? Height. Let's prove it. Let's prove that A is equals what we have on our right hand side. Let's prove it. Let's prove it. How do we prove that? Now, area is length equals, I told you that we have to neglect these idiots. Okay, that is, area is L squared, like length times length. Now base times height, distance. So it is very, very correct. So they are both correct. Please, strain is dimensionless. Strain is what? Dimensionless. And coefficients of friction, I don't know if I've deduced that before. Coefficient of friction is also what? Dimensionless. How? You know, coefficient of friction is given as frictional force over what? Normal force. Frictional force over what? Normal force. The frictional force is mg sine theta over mg cos theta. So this will go into this, and theta is what? Dimensionless. So coefficient of friction is what? Dimensionless. It does not have dimension. It does not have dimension. Take note of that. So I think at this point to call it a day. If there are more questions I have to solve, okay, let me round off with this. Let me round off with this. Now, what is dimension of Newton's universal law of gravity? Newton's universal law of gravity. Newton's universal law of gravity. Newton's universal law of what? Gravity. Now, what did the law say? The law states that that is the product of two masses. All right. The force that takes an object to the atmosphere is directly proportional to the product of the masses. Is what? That is, you say the force of attraction, better put, the force of attraction between mass 1 and mass 2 is directly proportional to the what? Product. That m1 times m2 is what? m1 m2 is inverse proportional to the square of the distance that separates them apart. You see the force of attraction that joins two masses m1 m2, which is their product, is inverse proportional to the square of the distance that separates them apart. So I have that F is equals big letter G. Now big letter G is Newton's constant, Newton's universal constant. So I'll say m squared. For me to say m1, m2, I'll say what? M squared equals what? R squared. I'm making this what we are looking for. I want to make it the subject formula. So this becomes fr squared equals what? Gm squared. Divide both sides by m squared. So I have that g is equals what? Fr squared over what? M squared. Very easy. Force, as deduced before, force is LT minus 2. Then arrow is distance, which is what? L2. The mass, you have two masses. Now, if one mass should cancel out one mass, I'm still left with what? One mass. Now, this one mass will go up. It becomes m raised power minus 1. Then I have invisible plus, I have plus 2 here, and I have plus 1, and this becomes what? L3 and t minus what? 2. Therefore, in case I ask you that, prove that, okay, how there's a way they usually put this question, um, how, okay, how is x, y, and z dimensionally the same as maybe force, gravity, or what? Force, acceleration, or velocity, as the case may be. Now it means that x is to m, y is to l, and z is to what? T. Now it means that x in this case is what? Minus 1. Then y in this case is what? 3. And z in this case is what? Minus 2. All right, so please take note of that. At this point, we call it a day. Thanks for watching. Do have a wonderful day. Please subscribe.